The core mission of the Energetic Materials Center is national security. So we are the focal point for the subject matter expertise in energetic material science here at Lawrence Livermore. We support the weapons program, and we also support global security engagements, all the way from supporting the deterrent to working for TSA baggage scanners and Homeland Security.
Over the last 35 years, the Energetic Materials Center has pivoted significantly. Came about at the end of Cold War era underground testing, where the DOE was pivoting to a science-based approach to qualification and certification of the nuclear deterrent. Along those lines, what we did was assemble staff, capabilities, and facilities that aren't replicated anywhere else in the United States or internationally to address these critical issues.
At the National Ignition Facility and other user facilities, we use high-power lasers to drive a compression wave through a high-explosive target. This brings the target to extreme temperatures and pressures, often exceeding the detonation conditions. We then probe the high-explosive target using state-of-the-art diagnostics, like X-ray diffraction, to understand both the chemistry and reaction products that form from these high-explosive reactions.
Continuum modeling is the art at looking at the system as a whole, treating your materials as being uniform, and using simplified physics in order to get large answers to questions. So the Cheetah Thermochemical Equilibrium Model is a tool that we've developed here at Lawrence Livermore to be coupled with our hydrocode simulations. These models, when working in conjunction with one another, allows us to make predictions about material properties under very reactive dynamic states. So predictive capability is the hallmark of the Energetic Materials Center's work because performing experiments is expensive. By setting up models and simulations, we can run a vast number of these simulations to get answers much quicker and potentially more accurately.
Atomistic simulations really are our foundation. They inform the basics that get incorporated all the way up to our engineering models. El Capitan is enabling us to perform the first all-atom simulations of realistic microstructure of an energetic material. The sorts of questions I'm most interested in tackling with El Capitan will really enable us to design better materials, better formulations for the future deterrent.
Livermore's been investing a lot into robotics and automation as a means of helping us do our work faster, more efficiently, and coupling that with machine learning. We have several systems that's being used to weigh out energetics. So this is both a safer way of being able to measure these samples and also a higher throughput way. We're also using that system as well as other larger, more complex systems to explore chemistries, new reactions, and to also be able to print materials in a higher throughput manner.
It's really important to scale up from the lab scale to the pilot scale to catch all the variables that you don't see at lab scale and be ready to manufacture material at full manufacturing chemical production scale. Our work to develop processes on the pilot scale bridges R&D and our national security challenges because it's essential to have our production partners effectively making material at the large scale, and we need to connect large-scale production and the lab-scale work, and our pilot equipment bridges this gap to connect them together.
I believe the Energetic Materials Center has a very exciting future. There are several things I'm interested in seeing how they develop. The application of exascale computing and how that will help us understand energetic materials better, how that will help us understand the science of them, the performance, the safety, as well as the mechanical properties. In addition, I'm also excited to see how we will transform the manufacturing base that provides the energetic materials that are utilized by the nuclear deterrent and global security.
We are doing work here that is accelerating the deterrence. We make sure that this nation and this country has the best science that they can bring to bear on difficult problems that enable national security. I want to say that at the Energetic Materials Center, we're having a blast. And for us, having a blast means innovating, doing new things, keeping other people safe, asking questions, and enjoying what we do. And I'm looking forward to us having a blast for the next 35 years.